There must be some way out of here, said the joker to the thief. There's too much
Okay, 8.2 is on arithmetic series. Last time we looked at arithmetic sequences. This time it's arithmetic series. So what's the difference? An arithmetic series is the sum of the terms in an arithmetic sequence. What does that mean? Well, last time we talked about sequences. An example of a sequence would be like 6, 10, 14, 18, 22. Why is that an arithmetic sequence? Because it has a common difference. It's going up by 4 every single time, right? Want it to be a series? Here's all you do. Just make it plus 10 plus 14 plus 18 plus 22. It's really that simple. If you take a sequence and just add all the terms together, you end up with a series. So let's get rid of this so you don't get confused and move this up, and we have our example right there of an arithmetic series. Series can be finite or it can be infinite. So for example, what I've written right here, 6 plus 10 plus 14 plus 18 plus 22, that is obviously a finite series because it ends, but I could put plus ... and then we have an infinite series. It goes on and on forever. So there's a couple formulas that come into play with arithmetic series. The first one we'll talk about is this one. S sub n equals n times a plus t sub n over 2. Okay, first of all, S sub n is the sum of the first n terms. So just to help you understand that, if I said S1, and I'm talking about, and we're looking at this series right here, this purple series right here, S1, what that means is, what's the sum of the first one term? Well, that's not very interesting. It's just 6. That is the first term. But if I said S2, it doesn't mean what's the second term. It means what's the sum of the first two terms. So it would be 6 plus 10 equals 16. Right? And I could do that for anything. I could do S sub 5. And then what I'd be adding together is 6 plus 10 plus 14 plus 18 plus 22. I'd be adding them all together. What's really interesting, and what we'll do later on, is when you're adding a S sub infinity. So in other words, you're adding together an infinite number of terms. Now you're probably rolling your eyes and saying, well, Mr. Waj, if you're adding together a bunch of numbers that are getting bigger and bigger and bigger, and there's an infinite number of them, obviously the answer is going to be infinity. And sometimes that's true, often it's true. But here's one of the coolest things in math, I think, that sometimes when you're adding together an infinite number of terms, you actually get a finite sum. Whoa, kind of mind-blowing, and we'll talk about that in a few more classes. Okay, so this is one formula you're going to use a lot, and then there's another formula we're going to use, and in order to get the other formula, maybe what I will do is I'll kind of generate it with you. Remember last time we had this formula? T of n equals a plus n minus 1 d. Well, if you look, in this new formula we've just given you, there's a t of n right there. And so what that means is, where I see t of n, I could write this down, because that's what t of n is equal to. So let's do that. Let's write this formula, s of n equals n times a plus, now I'm at this point, but I'm not going to write t of n, I'm going to write all this, because that's what t of n is equal to. So a plus n minus 1 d. And then it's all over 2. Now what we can do is we can simplify that. If we simplify that, the n's still there. Here's the one bit we can simplify. A plus a is 2a plus n minus 1 d over 2. And what I tend to do is put these actually square brackets all over 2. Okay, just so you know how I got this second formula, here it is. There's the second formula. By the way, if we look back at the first formula, let's talk for a second about what all these things are. N, just like last time, I don't think I'm going to write it down again, but we wrote this all down last time. N's the number of terms, A is the first term, T of n is the certain term, like the general term, and we said that often that'll be the last term. So in this formula, what you're basically doing is taking the first term, the last term, dividing them by 2, and then multiplying by how many terms there are. And there's a famous story about Gauss doing this that I'll probably talk to you about in class. I'm not going to spend time now talking about it because it'll take too much time, but pretty famous story. What else? So we've talked about n, a, and again, d. What's d? That's the common difference, right? Okay, so using these two formulas, you can figure out what series add up to. So here we have a series, 12 plus 18 plus 24 plus 30, blah, 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 all the way up to 54. Adding them all together, we want to know what the sum is. What do they all add up to? Now, of course, in this question, you could say, well, forget about all these formulas and everything. I'm just going to take my calculator, because you are allowed calculators in this chapter, just add them together. And you're right, you could, but the questions get much more difficult than this. We're going to have, determine the sum of the first 300 terms. You're not going to want to plug in 300 numbers into your calculator. So we should learn how to do it with the formula. Why don't we write down what we know in this case? Do we know A, the first term? Sure, the first term's 12. Do we know D, what the difference is? Yes, we do. Remember, if you don't know how to get D, take any two consecutive terms and subtract the previous one from the latter one. So 18 minus 12 equals 6. Or 24 take away 18 is 6. 30 take away 24 is 6. So there you go with that. T sub n. Do we know what the last term is? I mean, how many terms are we interested in? We're interested in 8 terms. So in other words, it's kind of like, what's T8? What's the 8th term? Well, 1, 2, 3, 4, 5, 6, 7, 8. The 8th term is 54. Do we know what n is? Yeah, I just kind of said that. The number we're interested in here, the number of terms we're interested, the number of terms there are here is 8. So we've got that too. Geez, what don't we have? Well, the only thing we don't have is S sub n. We don't know what the sum of them is. So that's what we're going to figure out. So you could actually use either one of these formulas. I think you'll find this one's a little bit easier. So let's use that one. S sub n, but rather than saying S sub n, why don't we say S sub 8? Because that would mean the sum of the first 8 terms, and that's exactly what we're interested in, is equal to n a plus t. Again, instead of saying n, why don't we say t8, since that's what we're interested in, over 2. So if we do that, we will have n, which is 8, times a, which is 12, plus t8, which is 54, all divided by 2. You could do this in a bunch of different ways. You could actually divide the 8 by 2 right now if you want. I mean, you can use your calculator, whatever you want. 12 plus 54 is 66. So if you multiply 4 times 66, you get 264, and that's your answer. The sum of those 8 numbers, if you were to add them together, is 264. Alright, let's determine the sum of this series. Now what's different about this one than the previous one? Are they both finite? Yes, they are. Even though this one has dot, 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 it has an ending number too. So this is actually a finite series, as is this one. But what's different about these two? The difference is in this one, you know how many terms there are. There's 8 terms. It says here, or you could just count them up. Here, you don't know how many terms there are. So that's going to make this question a little bit more difficult. So let's see what we do know. Do we know what A is? Yes, we know the first term. It's 8. Do we know what the difference is? Yes, we can calculate that. Take any 2 terms. I'll take the 8 and the 3. Take the second one of them, subtract the first one, and we get negative 5. If it's negative, it must be a decreasing series. And it is. They're getting smaller and smaller and smaller and smaller. Do we know what t of n is? In other words, kind of the last term. Yeah, we have a last term. It's negative 102. Do we know n, how many terms there are? No, we don't know how many terms there are. Do we know s of n, what the sum is? No, that's what we ultimately want to figure out. So, which formula can we use? The key thing to note here is we don't know n. So if we try to use this formula, it's not going to work. We don't know n. So maybe it's the second formula, or the first formula we use. No, we don't know n in that one either. Boy, we're kind of stuck here. So if this happens, that you need to know n, you don't know n, I can tell you right now, you're going to use the same formula we used last time. You're going to use that formula to figure out what n is. So let's start by doing that. T of n equals a plus n minus 1 times d. So t of n, we know it's negative 102. A we know it's 8. N we don't know. And d is negative 5. I'll put it in brackets like that. I like to subtract the 8 first, so I get negative 110, equals, let's do the mountains, negative 5n. Negative 5 times negative 1 is plus 5. So I subtract 5 from both sides. I get negative 115 equals negative 5n. Remember, n has to be positive, has to. And it's going to work out being positive because we're dividing by a negative. And if you do that, you will get that it's 23. N is 23. Great, now we know that the n value is 23. Now we can actually use either one of these formulas you want. So again, why don't we use the first one? It's a little bit easier to use. So S of n, or S of 23 actually, we know how many terms there are. S of 23 equals n times a plus term 23. We now know that this number right here, this negative 102, rather than just calling it t of n, we could call it t23. We know it's the 23rd term now. And then we divide it by 2. So it equals 23, which is n. A is 8, plus the 23rd term is negative 102, all divided by 2. I don't want to divide that because it gives me a decimal, so I'll just keep that. 23, 8 plus negative 102 is negative 94 over 2. You could divide the negative 94 by 2 now, so you'd get 23 times negative 47. You can do this any way you want. Use a calculator or whatever. And then once you multiply 23 times negative 47, you'll get the answer, which is negative 1081. Okay, next question here. We're finding the sum of the first 11 terms, and you only know the first 3. Wow. Alright, so let's see if we know what A is. Yep, that's the first term, 40. Let's see if we know D, what the difference is. Sure, we can figure that out. We could do 35 minus 40, which is negative 5. Do we know Tn, what the last term is? No, we don't. And in fact, we can say more than T of n, because you'll see in a second. And how many terms are we that we're interested in? We're interested in the first 11 terms. So rather than call it Tn, you could call it T11. Okay, do we know what the sum of the first 11 terms is? No, obviously that's what we're trying to figure out. So we do know n in this one, but we don't know the specific term. So let's go back and look at those formulas and figure out which one will be useful. We know n, so that's good for both of them. But we don't know the specific term. We don't know the Tn. So it looks like we're going to have to use this slightly more complicated one here. Or the other thing you could do is to use this formula first, the one that we've used last day, and then plug the Tn value into here and solve it that way. To tell the truth, I often do it that way, so I only have to memorize this one formula. But since I'm going to give you both formulas, I probably go with this one. Then it's only a one formula that you need to use. So let's go with that. We're trying to figure out S11, the sum of the first 11 terms. So the formula is n times 2a plus n minus 1 times d, all divided by 2. And you'll find with this chapter, it just becomes a plugging in question all the time. So we're plugging in the 11, we're doing 2 times 40, plus n is 11 minus 1 times the difference, which is negative 5, and we're dividing all that by 2. So do it in the right order. Brackets first, 2 times 40 is 80. Let's do this in one step. 11 minus 1 is 10 times negative 5 is negative 50. Whoops. And we're going to divide by 2. So we get 11 times 80 plus negative 50 is 30. And we're going to divide by 2. I could do that division right there. So I get 11 times 15. And 11 times 15 is 165. At first, you might think that answer doesn't look correct. I mean, if you add these together, you've got 40 plus 35 is 75, plus another 30 is 105. We still have 8 more numbers to go, and we're only going up to 165. But remember, these numbers are getting smaller and smaller and smaller. They're going to get down to the negatives, and that's why the number's not going to go quite as big as you think it might go. Okay, next. The sum of the first 14 terms is 574, and the difference is 6, then find A. So let's go through what we know. Do we know A? Obviously not. That's what we're trying to find. Do we know the difference? Yes, we do. It's 6. Do we know a term, I guess, 14? No, we don't know term 14. Do we know what n is? Yes, we do. The number of terms we're interested in is 14. And do we know what S14 is? Yes, we do. The S14 is 574. So we have n, and we don't have the 14th term. We don't have the Tn. So again, it's probably not going to work to use this one because we don't know Tn. We're probably going to use this big one again. So let's try that. I will write that complicated formula down again. And it is S of n equals n 2a plus n minus 1 times d all over 2. And we're going to plug in, and hopefully there's only one thing we don't know, and I think it will work. S of n, or S of 14, is 574 equals n, which is 14. 2 times a, we don't know a, that's our one unknown, plus n again, which is 14 minus 1, times the difference, which is 6, all divided by 2. So it's good. We only have one unknown. We can solve this. Let's multiply both sides by 2. If you multiply this side by 2, that'll cancel out. 2 times 574 is 1,148 equals 14. 2a. Why don't we do this? 14 take away 1 is 13, and 13 times 6 is 78. Okay, you could do mountains here. That's fine. Go for it if you want. Or if you want, you could divide by 14. Either way will work. If you divide by 14, you get 82, and you're left with 2a plus 78. Take away 78, take away 78. 4 equals 2a. Divide by 2, divide by 2. You get your final answer, a equals 2. So the first term in this series is 2, and then you go up by 6. You go 2 plus 8 plus 14 plus 20, and when you add all 14 of those numbers together, the sum would be 574. Okay, this last question is kind of a strange one. It kind of seems that we should have done this last day. Basically, when they're talking about arithmetic means between 8 and 29, it means if you had the number 8 and the number 29, what numbers would have to go here and here to make this an arithmetic sequence? Or an arithmetic series if you want to put plus and plus and plus. That's not so important. What's important is what numbers go here and here to make this an arithmetic sequence. So we kind of did this last day. If you started at 8, what would you have to do to get this number? You'd have to add a d. What would you have to do to get this number? Add a d. And what would you have to do to get this number? Add a d. So our formula we can create is 8, the starting number, plus how many d's? 3d equals 29. Solve that little simple equation. 3d equals 21. Divide by 3. You get d equals 7. Now we can figure out the numbers. If it's 8 here and the difference is 7, the next number is 15. And the difference is 7. The next one is 22. We can even check our work. The next number would be 22 plus 7 is 29. We got it right. Okay, so that's all they mean by arithmetic means. Okay, there you go. You now know arithmetic sequences and arithmetic series.
But you and I, we've been through that, and this is not our fate. So let us not talk falsely now.